Okay, so I've written a very simple program on Mathematica here. A is going to be the number of people. Probably should have called it n, but with 2 people. And p is going to be my probability.
All right.
Okay. We're just going to go through a loop. So for I equals 1, I less than or equal to the number of people, and we'll increment.
Right.
Probability is on the top we have 365
Nice.
minus a minus 1, but I think I made a mistake there. With one person we want the probability to be 1, right?
Yeah. Sweet.
And if a was 1, I would be subtracting 2 here. So I don't want minus a minus 1. What do I want?
Minus a plus 1.
Minus a plus 1. And now I know if a is 1, I'm just going to be multiplying by 365 over 365.
Yeah, wouldn't it be over 365 to the a?
Well, that's a good question. So I'm multiplying through my for loop here. I'm multiplying, I have a steps. 1, 2, 3, 4, 5 up to a. So each time I multiply by 365. So for the first person, I multiply by 365 minus 1 plus 1. So 365 over 365. For the second person, I multiply by 365 minus 2 plus 1, which is
64 to 365.
so
Okay.
here for 2 people. When I do the evaluation here, hopefully we get 364 over 365. But we did not. Okay, so what went wrong?
Yeah, 132, 486.
Is p something else in Mathematica? Or can you just use it as a variable?
It's a variable. I set it equal to 1 up here.
All right.
For I equals 1, I less than or equal to a is 2, I less than or equal to 2.
I.
Okay, so let's see what we got here. So 365, am I still on screen here?
Yeah.
Squared is 13325.
Alright, so that's on the bottom.
365
Oh, I think I see what we got.
times 364 is 132860. Oh, look what I did. It's a small little programming mistake. A isn't the variable. I is the variable.
Ah, there we go.
So I multiplied, this must be 364 times 364. Right? So tiny little mistake.
So we got 364 or 365.
Okay, so that's for a equals 2. Now for a equals 3, let's just double check. We hopefully are going to get 364 times 363 over 365 squared.
365 squared is on the bottom, yep.
And then let's check 364 times 363. Am I still on screen?
The output. I think the output is, but then this number is not.
Okay, well, 364 times 363 turns out to be 132, 132. So we got the right answer up here.
All right.
Okay?
It looks like it's working.
And so now we just want to find when this probability of having everyone with the same birthday being different,
0.
less than a half.
5, yeah.
Okay? So let's go to 20.
Wow, that's a big
It's-
number. All right.
Well, that's a big fraction.
0.588.
So we're still a little above.
Okay. 21.
556.
22.
2, 3, 4, 9.
There we go.
So with 23 people in the room, it's slightly less than 50% chance that everyone has a different birthday.
Wow.
Okay.
Doesn't make a lot of sense.
What?
Doesn't make a lot of sense.
Why do you say that?
Well, I mean, the probability, if you need 365 people, or 366 people in a room to have the probability of 2 people having the same birthday be 100%.
Uh-huh.
But you only need 23 people to have the probability be 50%.
That's right. It's a surprise.
Yeah.
But the math is fairly straightforward.
Yep.
And let's see what the probability is if you had 30 people in a room. So let's see how quickly it falls. So what do you think it's going to be with 30 people in a room to have everyone have different birthdays?
Maybe like 30%?
30%? What's your guess?
Yeah, around 30%.
29.
Wow.
So it's nowhere near 30%. Oh wait, it's almost exactly 30%.
Yeah.
Okay, so with 30 people in a room, now what about with 50?
I'm gonna
50
guess,
people in a room, everyone has different birthdays.
I'm gonna guess it's gonna be maybe like 0.05
0.05% or 5%?
or 0.05.
Okay, so 5%
Yeah,
chance. Everyone has a
5%.
different birthday.
I'm
What do you
guessing
think?
around 10%?
10%? Okay, 5% versus 10%.
0.02.
So it's about 3%.
That's actually about 1/10 of what we had for 30 people.
Yeah. And now let's go to 60 people. Just a small increase.
0.01.
So you think 1% chance?
Yeah.
I'm guessing 0.001.
So you think it's 1 in 1,000, okay?
0.005.
Alright, so it's sort of in between. 1 in... close to 1 in 200.
Yeah.
And with 100 people in a room, what do you think?
0.
In fact, I'm going to get rid of p just because it's silly at that point, and I'm going to do 1 divided by np. So we see 1 in how many? What do you think with 100 people? 1 out of how many?
Maybe 1 out of a million.
1 out of a million? What do you think?
Maybe 1 out of a million.
1 out of 3 million?
Wow.
So with 100 people in a room, like you will never be in a room of randomly selected people with 100 people in a room and everyone having a different birthday.
Yeah.
It's a 1 in 3 million shot. So that'll probably never happen.
Yeah.
All right, what do you guys think of this?
It's pretty cool.
Pretty neat.
Yeah, it's pretty cool. It's a good probability exercise as well. All right, high five. Good work, guys.